You are holding a rock. It is black, smooth, and sharper than almost anything you have ever touched. You did not make it. You found it near a volcano, buried among grey volcanic stone. When you strike it against another rock, it breaks with a strange, curved edge, thin enough to cut skin before you even feel the pain. This is obsidian, volcanic glass. Hundreds of thousands of years ago, one of your human ancestors picked up a piece of this material and discovered something almost impossible to ignore. It could cut. At sites in East Africa, including Kariandusi in Kenya's Rift Valley, early humans were shaping volcanic glass into razor-sharp tools long before anyone understood what glass actually was. Think about that. Glass existed long before humans knew how to make it. Volcanoes had been producing it for millions of years. Lightning could strike sand and fuse it into hollow tubes called fulgurites. Meteorite impacts could melt enormous areas of desert sand into sheets of natural glass. Nature had already mastered the recipe. Humans simply had not figured out how to copy it. And then, thousands of years later, someone did. Not because they were trying to invent one of the most important materials in human history, probably because something went wrong, or perhaps something went unexpectedly right. So how did humans go from picking up volcanic glass to making windows, mirrors, microscopes, fiber optic cables, and the screen you are looking at right now? The answer takes you through ancient kilns, Egyptian palaces, Roman workshops, Islamic cities, Venetian secrets, scientific revolutions, and a few accidents that changed the world. But first, there is something you need to forget. Glass is not a liquid. You may have heard the story that old cathedral windows are thicker at the bottom because glass slowly flows downward over centuries. It sounds reasonable. It is also wrong. Physicist Edgar Dutra-Zanotto examined the idea mathematically and showed that ordinary glass at room temperature would take vastly longer than the age of the universe to flow enough for the effect to become measurable. So why are medieval windows often uneven? Because medieval glassmakers made uneven glass. One traditional method involved spinning molten glass into a large circular disc. The resulting disc was not perfectly uniform. One side could be thicker than another, and when the window was installed, the heavier side was often placed downward. The glass did not slowly crawl toward the ground, it was manufactured that way. But what glass actually is, may be even stranger. Glass is an amorphous solid. In simple terms, its atoms are locked into a disordered arrangement rather than the neat, repeating structure found in a crystal. Imagine freezing a liquid before its molecules have time to organize themselves. That is roughly the idea. When many substances cool slowly, their atoms arrange themselves into repeating patterns. Crystals form. But when certain molten materials cool without allowing that organization to happen, the atoms become trapped in a chaotic arrangement. The material becomes rigid. It behaves like a solid, but internally it never developed the orderly structure of a crystal. That unusual structure is one reason glass can do things that seem almost contradictory. It can be hard, but transparent. It can be fragile, but chemically resistant. It can be shaped while hot, then locked into almost any form. And most ordinary glass begins with something incredibly common: sand. The main ingredient is silicon dioxide, or silica. Pure silica, however, melts at around 1700 degrees Celsius. That is an enormous amount of heat, far beyond what most ancient furnaces could easily maintain. So ancient glassmakers needed a trick. They added a flux, a material that lowers the temperature required for melting. One important ancient flux was natron, a naturally occurring mineral rich in sodium carbonate found in places such as Egypt's Wadi Natron. Then came another problem. A mixture of silica and alkali could produce a glass that was too vulnerable to water. So glassmakers added a stabilizer, usually lime or calcium oxide, obtained from limestone or similar materials. The basic recipe was remarkably simple: silica, soda, lime. 3 ingredients. Heat them together and an entirely new material emerges. The surprising part is that versions of this basic chemistry are still at the heart of common soda-lime glass today. A recipe developed thousands of years ago never really disappeared. But who discovered it? For centuries, people had an answer. A Roman writer named Pliny the Elder told a famous story about Phoenician merchants camping near the river Belus. According to the story, they used blocks of natron to support their cooking pots. The heat supposedly melted the natron together with the beach sand, creating the first glass. It is a beautiful story. It is also almost certainly a myth. A normal open beach fire does not reach the temperatures required to produce the kind of glass described in the story. The real beginning was probably much less dramatic. There was no genius standing on a beach watching a glowing river of glass pour from beneath a cooking pot. Instead, the first glass may have appeared as an unwanted side effect of another technology. Around the middle of the 3rd millennium BC, small glass objects began appearing in Mesopotamia and Egypt. Among the earliest examples are beads. At the time, craftsmen were already producing faials, a quartz-rich material coated with a glassy surface, and inside hot kilns, silica-rich materials mixed with alkaline substances could vitrify. Vitrification simply means that the material transformed into a glass-like substance. Someone eventually noticed that shiny layer was not just waste, it could be separated, colored, shaped, used. Another possibility is that glassmaking developed from the glassy slag produced during metalworking, including copper smelting. Archaeologist A. Leo Oppenheim explored this possibility in his work on ancient Mesopotamian glass. The exact moment remains uncertain. And that uncertainty is important, because inventions rarely arrive with a birth certificate. Sometimes an invention is not a single brilliant idea. Sometimes it is an accident repeated until somebody realizes the accident is useful. There is also evidence that Egypt and Mesopotamia may have developed glass production independently. Chemical analysis of ancient glass has revealed different trace element signatures associated with different raw materials. In other words, 2 civilizations may have been solving the same chemistry problem separately. No inventor, no patent, no instruction manual, just humans experimenting with fire until something strange happened. And for a very long time, glass remained incredibly valuable. Imagine holding a glass object around 1500 BC. You are not holding an ordinary household container, you are holding something rare, something associated with palaces, temples, rulers, and international diplomacy. During the Late Bronze Age, glass could be valued alongside luxury materials such as lapis lazuli, turquoise, and gold. Letters from the Amarna period even contain complaints about the quality of glass exchanged between rulers. Imagine that. A king is not complaining about a shipment of food. He is complaining that the glass he received was inferior. Glass was a status symbol. At Amarna, the capital associated with Pharaoh Akhenaten, archaeologists discovered evidence of specialized glass production. Glass rods, colored materials, ingots, partially finished objects, furnace remains. The evidence suggests that ancient craftsmen used a surprisingly sophisticated 2-stage process. First, raw materials were partially melted into a rough material called frit. Then the frit was crushed and melted again to create better quality glass. This was not primitive guesswork, it was controlled, high-temperature chemistry. 3,000 years ago, And ancient Egypt offers another extraordinary connection between glass and deep time. Inside the tomb of Tutankhamun was a carved scarab incorporated into a ceremonial object. For decades, the stone was identified incorrectly. Later analysis showed that it was actually Libyan desert glass, a rare natural glass found in the Sahara. This material formed millions of years ago, probably during an extreme high-temperature event associated with a meteorite impact or airburst. Desert sand melted, then cooled, long before humans existed. Millions of years later, an Egyptian craftsman found a piece of it, carved it into a sacred symbol, and placed it on the chest of a young king. The craftsman did not know the glass came from a cosmic event. He did not need to. It was beautiful, and beauty was enough. But ancient glass still had a major problem. It was painfully slow to make. Early vessels were often produced using a technique called core forming. A craftsman shaped a temporary core, often from clay and organic material, around a metal rod. Then hot glass was wrapped around the core. The surface was shaped and smoothed. After the vessel cooled, the core was removed. The result could be a tiny perfume bottle or container, beautiful, delicate, expensive, and extremely labor-intensive. For centuries, hollow glass meant slow glass. Then someone changed one simple thing. They breathed. Around the 1st century BC, probably somewhere in the eastern Mediterranean, craftsmen began attaching molten glass to the end of a hollow tube. Then they blew air into it. The glass expanded. The shape could be controlled from the inside. Glassblowing had arrived, and suddenly everything changed. A vessel that once required hours of skilled work could now be produced far more quickly. Glass became thinner, lighter, larger, cheaper. The technology spread rapidly through the Roman world. The Romans did not invent glassblowing, but they industrialized its possibilities. Workshops produced bottles, bowls, cups, storage containers, and other objects on a scale earlier civilizations could not easily match. Glass stopped being something only the elite could possess. It became an everyday material. And then, the Romans did something even more important. They put glass into walls. Archaeological evidence from Roman sites such as Pompeii shows the use of window glass. It was thick. It was not perfectly transparent, but it performed a revolutionary trick. It allowed light in while keeping weather out. A transparent wall sounds ordinary now. It was not ordinary then. Somewhere in human history, somebody looked at a solid wall and realized that part of it could be replaced with something you could see through. That single idea would eventually transform architecture. But ancient glass could do something even stranger. The Roman Lycurgus cup changes color depending on how light passes through it. From one direction it appears green, from another it becomes reddish. For centuries, nobody fully understood why. Modern analysis revealed an extraordinary secret. The glass contains tiny particles of gold and silver, measured in nanometers, far smaller than anything visible to the naked eye. These nanoparticles interact with light in a way that changes the apparent color of the cup. In other words, Roman craftsmen were manipulating matter at a scale they could not see. They did not have the language of nanotechnology. They did not have electron microscopes. They simply discovered that certain mixtures produced astonishing results. After Rome, glass innovation continued in the Islamic world. Glassmakers working across regions such as Syria and Egypt developed sophisticated techniques involving enameling, gilding, and metallic decoration. Mosque lamps became some of the most recognizable achievements of Islamic glassmaking. Then political power moved, wars moved, people moved. When Timur captured Damascus in 1400, craftsmen were reportedly taken to Samarkand. Knowledge traveled with them. Meanwhile, Venice was building its own glass empire. In 1291, Venetian authorities ordered glass furnaces moved to Murano. Fire prevention was the official explanation. But controlling knowledge was also enormously valuable. Glassmakers possessed secrets worth protecting. Their skills were so important that the Venetian state granted them unusual privileges, while also restricting their freedom to leave. Glass had become more than an object, it had become strategic technology. Then, around the 15th century, Angelo Barovier became associated with an especially clear form of Venetian glass known as cristallo. By carefully purifying raw materials and controlling impurities, glassmakers could produce material that looked remarkably similar to clear rock crystal. And once glass became clearer, another possibility opened: reflection. Before modern mirrors, people mostly saw themselves in polished metal. The image was dim, distorted, expensive. Glass changed that. Eventually, improved mirror-making techniques created much brighter reflections, and by the 19th century, chemical silvering replaced older mercury-based methods. Now you could look into a mirror and see yourself with startling clarity. But glass was about to become even more important. It was going to change what humans could see. Eyeglasses appeared in northern Italy by the late 13th century. For people whose close vision deteriorated with age, lenses could restore the ability to read. That mattered enormously in a world where books were becoming more common. Then came the telescope. In the early 17th century, lens makers began combining curved pieces of glass to magnify distant objects. Galileo improved the design and pointed one toward the night sky. He saw 4 moons orbiting Jupiter, 4 tiny points of light, moving around another world. A simple observation through glass helped undermine the belief that everything in the universe revolved around Earth. Then another lens turned in the opposite direction. Antony van Leeuwenhoek, a Dutch craftsman with no conventional scientific career, produced extremely powerful small lenses. He used them to observe microscopic life, including bacteria and sperm cells. Suddenly, the universe was not only larger than humans had imagined, it was smaller too. Glass opened both doors. And sometimes, glass changed the world because it failed. In 1903, French chemist Edouard Benedictus accidentally dropped a glass flask. It cracked, but it did not completely shatter. A thin, transparent film left inside the flask had held the broken pieces together. Benedictus recognized the potential. His work helped lead to laminated safety glass. Eventually, this technology became essential for automobile windshields. Another revolution came in the 20th century. Flat glass had traditionally been difficult to manufacture perfectly. Then Alistair Pilkington developed the float glass process. Molten glass was poured continuously onto a bath of molten tin. Because the glass floated, it could spread into an exceptionally flat sheet. As it cooled, the surface became smooth and uniform. The process transformed modern windows. And then glass became something almost invisible, a thread. In 1966, Charles Cow argued that ultra-pure glass fibers could transmit information using light. The problem was impurities. Tiny imperfections scattered the light and weakened the signal. Make the glass pure enough, Cow realized, and light could travel enormous distances. In 1970, researchers at Corning produced practical, low-loss optical fiber. The consequences were enormous. Today, hundreds of millions of kilometers of optical fiber connect the planet. A huge portion of international internet traffic travels through glass fibers beneath oceans and across continents. The internet is, in a very literal sense, traveling through glass. And then glass entered your pocket. In the 1960s, Corning developed chemically strengthened glass through ion exchange. The project did not immediately become a commercial success. The technology sat dormant for decades. Then, in the early 2000s, Apple needed a strong, scratch-resistant material for a new touchscreen device. The old research suddenly became valuable. The result became Gorilla Glass. A technology developed decades earlier found a new purpose inside smartphones. That pattern has followed glass for thousands of years. Something is discovered. It seems strange. It gets ignored. Then another generation finds a completely different use for it. So how did humans invent glass? The uncomfortable answer is that humans probably did not invent it in a single moment. There was no single inventor, no single workshop, no single civilization that can confidently claim the entire story. The first glass may have appeared accidentally during the production of faience, metalworking, or related high-temperature processes. Someone saw something shiny, someone did not throw it away, someone looked closer, and that habit changed everything. For thousands of years, glass was a luxury. Then glassblowing made it common. Then windows changed buildings. Mirrors changed how humans saw themselves. Lenses changed how humans saw the universe. Microscopes revealed an invisible world. Optical fibers turned the planet into a connected network. And strengthened glass put a piece of ancient chemistry into your hand. Think about what you are surrounded by right now. Windows, screens, cameras, lenses, light bulbs, fiber optic networks, laboratory equipment. Glass is everywhere. And yet its beginning was almost absurdly simple. Sand, heat, time, attention. A material that nature had been creating for millions of years became one of the most powerful technologies humans ever learned to control. And perhaps that is the strangest part of the entire story. Human progress is often remembered as a sequence of brilliant inventions. But the reality is messier, more accidental, more human. Someone makes something they do not understand. Someone notices an unexpected result. Someone asks a question. What if this isn't waste? What if this is useful? What if you look closer? Your ancestors did not begin with smartphones, satellites, microscopes, or the internet. They began by noticing that certain rocks could cut. Then that certain minerals could melt. Then that molten material could harden into something strange. And thousands of years later, that same basic material became the lens through which you see distant galaxies and the thread through which your messages cross oceans. All of it began with sand. And maybe there is a final irony here. You spend much of modern life surrounded by artificial deadlines, alarms, schedules, screens, notifications, and manufactured standards of success. No sunrise required, no animal tracks to follow, no fire to maintain, no place to be. Yet your brain still carries the biological machinery of a creature that spent almost all of its existence watching the horizon, reading weather, following seasons, and paying attention to tiny changes in the world. The people who first discovered glass did not have laboratories. They had fire, they had stone, they had curiosity, and most importantly, they had time to notice something strange. Today, you have almost everything they lacked. But perhaps you have lost the one thing that made the discovery possible. Attention. Because the history of glass is not really the story of how humans learned to melt sand. It is the story of what happens when someone refuses to ignore the unexpected. A strange substance appears where it should not be. Most people might scrape it away. Someone stops. Someone looks closer, and thousands of years later, you are staring through a piece of that discovery. So the next time you look through a window, touch your phone, check your reflection, zoom into a photograph, or send a message across the ocean, remember what you are actually holding. A piece of sand, transformed by fire, shaped by human hands, and carrying the accumulated curiosity of thousands of generations. Glass did not begin with a genius. It began with someone paying attention. And perhaps that is the uncomfortable lesson modern life has forgotten. The world is still full of strange things happening right in front of you. But when every hour is scheduled, every silence is filled, and every moment is pushed toward productivity, you may be surrounded by discoveries without ever having the time to notice them. Your ancestors looked closer. Maybe that is why they found a new world inside something as ordinary as sand.